power m dot a power n will be written as a power m plus n. This q root if I remove, it can be written as to the power of 1 by q. Accordingly, we are going to write it as a replaces x power 1 by 2, b replaces y power 1 by 2. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in this session, we are going to learn the chapter 3, Theory of Indices. Okay, then in which we are going to use this theory of indices when we need to calculate the power of the variables, and then we are going to use this theory of indices in further logarithms. Okay, now in this session what we are going to study under this chapter of theory of indices is introduction for theory of indices, and then you are going to have a proof of laws of indices, which is very important because based on these laws only you are going to do a problems. So to do the problems, laws of indices is a very basic proof or a basic things you are going to have, and then based on those laws of indices we are going to do 1 marker and then 2 marker problem which will be asked for your final examination. Okay, now let us move on to the theory of indices. What do you mean by that? What are all we are going to study? So the basics of indices is important for many calculation in algebraic equations, isn't it? So therefore there we are going to use, and in this chapter we have discussed the laws of indices. Okay, that means the proof, and then we are going to have problems based on those laws, and then this will be used further for, I told you already, to derive the logarithms. Got? So now what do you mean by the a power n? So anything power n, we are going to read that one as, see, if a is any real number and then n will be a non-zero positive real number. What we are writing? A power n. So this a is nothing but it belongs to R, that means real number. Okay, and then you are going to have this power n will be a non-zero positive integer. Are you going to get this? So here we are going to have, what do you mean by this a power n? How we are going to this a power n as? Suppose, for example, if I am having a squared, how we are going to split this one? A into a, that means twice you are going to write it as a squared, isn't it? Similarly, if it is there a cube, how we are going to split this? A into a, correct? That is nothing but the a power 3. Similarly, if it is there a power 4, how we are going to write? A into a into a into a. Therefore, if it is there power n, how we are going to write? Like this, a into etc. up to where terms? Up to n number of terms. Understood? This is how we are going to split a power n as. Now here a is called, particularly a is going to be known as, in the a power n, a is going to be known as base. We are going to call that one as base, and this we are going to call it as index, or we are going to name it as power, or also we are going to name it as exponent. Got? Exponent. So all this you have to remember, so that a particularly called as a base and n particularly called as the index or the power or the exponent. Understood? Now let us move on to the proof. The first law. What first law says as, if a is any non-zero real number, then we are going to have m and n are 2 positive integers. We are going to write it as a power m dot a power n will be written as a power m plus n. That means if you are having like this 2 power 3 into 2 power 2, we are going to write the base is same, correct? If base is same, powers to be added. Understood? So here you are going to add the powers 3 plus 2. In general, we are going to call this one as m, this one as n. M and N can be any integer. Here especially any positive integer we are going to take. Then what the proof will go? As I told you, a power n can be written as a into a to n number of integers. A power m can be written as a into a to the power of m, isn't it? So this you are going to multiply 6 times plus 5 times. So therefore you are going to have a dot a will be m plus n times. M plus n times. Therefore the proof will be a power m plus n. That's it. Is that so easy? Right. So if you are having next, similarly here I have taken some, correct? A power n, a power n, a power p, a power k, a power s, etc. can be written as, suppose if you are having 2 power 3, 2 power 4, 2 power 6, 2 power 8, so etc. you are having. So therefore you are going to write as the base is same. If the base is same is, a powers can be added. Therefore you are going to have 2 power 3 plus 4 plus 6 plus 8. Isn't it? So you are going to have 6 plus 4, 10, 18. 18 plus 3 will become 21. 2 to the power of 21 you can write it as. So this is how we'll go for this one. A power m, anything base you are having same, the powers can be added out. Okay. So we are going to use this also as a first law. Okay. Next we'll be moving on to the second law. What is that? If a is any non-zero real number and m and n are any two positive integers, then we are going to have a power m by a power n can be written as a power m minus n if m should be greater than n, and a power n minus m if m is lesser than n. What will be the proof? So I am going to take the left hand side, that is a power m divided by a power n. That means how we are going to prove that. So which will be, how we can write this? A into a up to m number of terms divided by a into a up to n number of terms, isn't it? Therefore we are going to have since here I can write it as since m is greater than n. So m is greater than n means this obviously if it comes to the numerator it will become negative. So therefore you are going to have it as a power m divided by a power n, which will be a power m minus n. That's it. Got? Similarly, you can prove this also. What is that? A power n minus m. What you are going to write it as? A into a power m divided by a power n can be written as a into a to m terms, a into a up to n terms. Since given that, what is that? M is lesser than n, isn't it? So this will come to the denominator. So therefore you are going to write it as 1 divided by a power n into a power minus m. So the base are same, you can add the powers. So a power n minus m. So this is what you are going to have for the, or you are going to have for the proof like this. Okay, n minus m. Understood? So next we'll be moving on to third law. What is the third law? If a is any non-zero real number, m and n are two positive integers, then a power m whole power n can be written as a power mn. So what will be the proof? You are going to have it as a power m can be written as a whole power n. I am going to write a into etc. up to m terms, correct? And then you are going to have it as power m, correct? Power n means again this will be whole power, correct? So that means you are going to have it as, which will be power of times, that is what? A power n, which will be n times. So you are going to have it as a power n, a into a up to mn times. So which will become a power mn. That's it. And this proof they are not going to ask you for the examination. They are going to ask you to solve the problems based on this proof. Understood? Next we'll be moving on to what will be the note. We are going to have it as, see, anything power 0. If a is a non-zero integer, then a power 0 will become 1. That means 2 power 0 will be 1, 3 power 0 will be 1, 5 by 3 whole power 0 will be 1, 1 by 2 whole power 0 will be 1. Anything power 0, you are going to write it as 1. Got? That is what we are going to use in laws of indices, the condition. Next will be, if a is any non-zero integer and m is any positive integer, then a power minus m, we are going to write it as 1 by a power m. That means 2 power minus 1 can be written as 1 by 2. 2 power minus 3 can be written as 1 by 2 power 3. This is 2 power 1. 2 power 1 is 2 itself. Okay. Similarly, 3 power minus 1 can be written as 1 by 3 power 1. 5 power minus 3 can be written as 1 by 5 power 3. Understood? So this is how we are going to write it as a power minus m. Next, if a is any non-zero integer and p and q are any positive integer such that q should not be equal to 0, then you are going to write it as square root of, that is qth root of a power p is equal to a power p by q. So you are going to have it as, see, observe here, you are going to write it as qth root of a power p. Now, you are going to take it as a power p. See, this qth root can be written as whole to the power of 1 by q. Okay. This qth root, if I remove, it can be written as to the power of 1 by q. Now, if you multiply, this is like a power m into n. What is a power m into n? Third law. M into n is m, and you can write it as. Therefore, I can write that one as a power p into 1 by q, which is p by q. That's what they have written there. Are you getting? So, we are going to use this also as the note or the condition for theory of indices. Next, if you are having one more, I can give you. See, if you are having like this, a by b whole to the power of minus m, you can write it as b by a whole to the power of m. That means you can change this. See, if you change this one, how you are going to write this one, I am going to show you. A power, this is a power minus m, you can split a power minus m divided by b power minus m. Now, if this goes to the numerator, minus m will become plus m. If this comes to the denominator, minus m will become plus m. So, that's how we are going to have b power m divided by a power m, which can be written as b by a whole power m. This also you need to remember. This is not a theory of indices law, but you are going to use this kind of in solving problems. Okay. Let us move on to solving the problems by using those properties. Simplify. 5 to the power of 5 power 0 plus 5 squared whole to the power of 0. So what you are going to do? First you are going to write it. What is a power? Power is what? 5 power 0. What is 5 power 0? 5 power 0 is nothing but 1. Correct? So therefore you are going to write here. See. 5 power 1. Correct? Plus 5 squared is what? 25. So 25 whole to the power of what? 0. Anything power 0 is what? Anything power 0, that is a power 0 is 1. Similarly, a replaces 5. Here a replaces 25. So 25 whole to the power of 0 is also 1. Correct? So you are going to have it as what is 5 power 1? 5 plus 25 whole to the power of 0 is 1. 5 plus 1 is 6. Is that so easy, dear students? This type of problem will be asked for 1 marker. Okay. We'll be moving on to the next problem. Simplify. A to the power of x plus y into a to the power of 2x minus y. Suppose if you are having like this, see, base are same. If the base are same, I can add the powers, isn't it? So by adding the powers, let us check what happens, which will be implies a power x plus y. This is m. So I am going to write it here. A power m, a power n can be written as a power m plus n. Right? M replaces x plus y, n replaces 2x minus y. So x plus y plus n, that is 2x minus y. So you are going to have it as c plus y minus y will get cancelled. X plus 2x will become 3x. A power 3x, right? Is that so easy, dear? Next we'll be moving on to the next type of problem. Simplify x to the power of 1 by 2 plus y to the power of 1 by 2 into x to the power of 1 by 2 minus y to the power of 1 by 2. Is that look like a plus b into a minus b? Dear students, a plus b into a minus b will be is equal to a squared minus b squared. So accordingly, we are going to write it as a replaces x power 1 by 2, b replaces y power 1 by 2. So therefore, if I am going to write according to the formula, you are going to have it as a power, that is a to the power of, correct now, you are going to have square, right? A squared minus b squared, b square, b replaces y power 1 by 2. Now we are going to have, this is like a power mn. What is a power mn? Here I am writing. So a power mn, that is a power m whole power n will be is equal to a power m dot n, correct? So m will be 1 by 2, n will be 2. So you are going to write it as a power m dot n x power 1 by 2 dot 2 minus y 1 power 1 by 2 dot 2. So here 2 will get cancelled, 2 will get cancelled. You are going to remain with the value x power 1 minus y power 1, which implies x minus y. That's it. So this type of problems also will be asked for 1 marker. Is that so easy? We'll be moving on to the next problem. Wow. Cube root of x squared whole to the power of 3 whole to the power of 1 by 2. Is it look like trickier? No, it is very easy, dear students. Here you are going to solve first the bracket thing and then you are moving according to the powers. So here you are having cube root of x squared. Is that look like cube root of a power p? What is cube root of a power p? Which can be written as a to the power of p to the power of 1 by q, which is nothing but a to the power of p by q. You are going to have, see, if I compare this one, cube root of x squared. So I am going to take that here. So cube root of x squared, is it look like the same? Q replaces 3 and a replaces x, p replaces 2. That's it. So therefore you are going to have what it will become? A to the power of, that is x to the power of, p replaces what? 2, correct? And q replaces 3. Does it look like that? Yes. So therefore you are going to have it as accordingly if you are going to write this one. Otherwise, if you cannot write, see, concentrate on these powers. First I am going to take this. Let it be. First I am going to take this and then I am going to write it accordingly. Then I am going to make it as whole power. Okay. So what happens here? Which will become, see, cube root of, what it will be? Here I have written, that is x to the power of 2 by 3 whole to the power of 3 whole to the power of 1 by 2. Let it be like that. So I am going to have it as here, see, x to the power of 2 by 3, which is a power m whole power n, which is like a power m whole power n. So therefore you are having formula a power m whole power n is a power m into n, which will be is equal to x to the power of 2 by 3 whole to the power of 3 whole to the power of 1 by 2 will be x to the power of 2 by 3 into 3 whole to the power of 1 by 2. M dot n, 3 will get cancelled. You are going to remain with x squared whole to the power of 1 by 2, which will be again a power m whole power n, which can be written as 2 into 1 by 2. So 2 into 1 by 2, 2 will get cancelled. You are going to remain with the value x power 1, which is nothing but x, right? Still in another way we can solve this problem. You can make a note of this one. I'm going to solve it in other way which will be very easier. See, we are having what? Cube root of x squared. I am going to consider that x squared as it is cube root of this power p. I am going to consider. What is that? Cube root of a power p will be is equals to a to the power of p by q. Isn't it? So here I am going to take it as this cube root of x squared whole power 3 as what? Which can be written as, see, this cube root can be written as to the power of 1 by 3, correct? So whatever you are having, see, square root of a can be written as a to the power of 1 by 2. See, this square root is there, 1 by 2. Similarly, cube root of a can be written as a to the power of 1 by 3. Fourth root of a can be written as a to the power of 1 by 4. Fifth root of a can be written as a to the power of 1 by 5. If you observe carefully here, this is if you consider it as a, x squared as a, cube root of a can be written as a to the power of 1 by 3. Okay, in place of a, you are having x squared. So what you are going to write it as? You are going to write it as x squared as it is, and this cube root can be written as whole to the power of 1 by 3. This 3 is already here, so which will become whole to the power of 1 by 3 into 3. This 3 as it is, I am going to write it. Right? Now again whole squared you are having, that is whole to the power of 1 by 2. That I am going to write it. Is that so easy, dear student? Now 3 will get cancelled. You are going to remain with x squared whole to the power of 1 by 2, which will look like a power m whole power n, which is a power mn. So which will be is equal to 2 will get cancelled. 2 into 1 by 2, which will be is equals to x to the power of 1. 2 will get cancelled, which will be is equals to x. Is that so easy, dear students? Yes. So this type of problems also will be asked for 1 marker. While simplification, be careful. Okay. So we'll be moving on to the next problem, which is nothing but the 2 marker. So you are going to have here a power 2m plus n dot a power 3m plus n divided by a power 4m plus 1 plus 2n. You need to simplify this one. See, base are same. I can add the powers. This will look like a power m, a power n divided by a power s, whatever it is. Right? Because mn I have taken here. Yes, I am going to take. So this can be written as a power m plus n. If this comes to the numerator, it will become a power minus s. Again, the base are same. I can add the powers. A power m plus n minus s, where m replaces 2m plus n replaces 3m plus n, s replaces 4m plus 2n. Okay. So here if I take like that, you can write this one as a power 2m plus n plus n, 3m plus n. This replaces n. Okay. If you are confusing m is there here, m is there, no. This you can change it the variable. What is that? I can change as well as, see, a power u, a power v, correct? That is a power u plus v. This is u plus v minus s. So u replaces 2m plus n, v replaces 3m plus n, s replaces 4m plus 2n. That's it. Okay. So you are going to have here, I am going to write it here, a to the power of, c. If it comes to the numerator, it will become negative. Since plus you are having, open the bracket, 4m plus 2n. So what this will become? Again, a to the power of 2m plus 3m is 5m. Again, plus n is plus 2n. Right? So a to the power of, see, minus into plus is minus 4m, minus into plus is minus 2n. Now again, base are same. I can add the powers. So what it will become? Adding a power 5m plus 2n. This is look like u, v. So minus 4m minus 2n, adding. So 5m minus 4m is, which will become a to the power of 5m minus 4m is m. 2n will get cancelled, and this is your answer. Is that so easy? Okay, let us move on to the next problem, which is nothing but simplify 2 power n plus 1 plus 2 power n minus 1 divided by 2 power n plus 2 power n plus 2. So here I am going to take accordingly a power u plus v can be written as a power u into a power v. That formula I am going to use it here. So therefore which will become, see, 2 power n into 2 power 1 plus this also same 2 power n into 2 power minus 1 divided by 2 power n as it is, plus this will become according to the formula 2 power n into 2 power 2. Correct? So next let us move on to by taking common factor. 2 power n here, 2 power n here, 2 power n, 2 power n. If I take common factor, what it will become? 2 power n into 2 power 1 plus 2 power minus 1 divided by 2 power n into 1 is remaining plus 2 power 2. Correct? So 2 power n will get cancelled. You are going to remain with 2 power 1 plus 2 power minus 1. What is a power minus m can be written as 1 divided by a power m. So 2 power minus 1 can be written as is 1 by 2 power 1, which is 1 by 2. So therefore you are going to write accordingly. This will be 1 by 2 power 1, which is 2 power 1. Denominator 1 plus 2 squared. What is 2 squared? 4. 4 plus 1, 5. So I am going to write it 5. Further simplification. This you can take LCM. If I take LCM, 2 2s are 4. Correct? So you are going to have your 2 2s are 4. 2 power 1 is 2. 2 power 1 is 2. So nothing will matter if I write it as 2 power 1 also and 2 also or 2 also, right? So 2 2s are 4. 4. 2 2s are 4 plus 1 divided by this 2 will come to the denominator. Correct? 2 into 5. Now what is this 4 plus 1? 4 plus 1 is 5 divided by 2 into 5. Now 5 will get cancelled. You are going to remain with numerator 1 and denominator 2 into 1 is 2. The answer will be 1 by 2. Is that so easier? So we have used here two theorems or two theory of indices, laws of indices. Okay. Next we'll be moving on to simplify x power a divided by x power b whole to the power of a plus b into x power b divided by x power c whole to the power of b plus c into x power c divided by x power a whole to the power of c plus a. How to simplify this one? So first it's look like a power m by a power n. What is that? A power m by a power n can be written as a power m minus n. Correct? So accordingly I am going to take this one as, so x power a minus b whole to the power of a plus b. Right? Similarly into, this is also looking like the same. So b replaces m and n replaces c. That's it. So it will become x to the power of b minus c whole to the power of b plus c. Similarly this also x to the power of c minus a whole to the power of c plus a. Now you can have, this is look like a power m into n. What is our a power m whole power n will be is equal to a power m n. So accordingly I can write that one as x to the power of a minus b into a plus b into x to the power of b minus c into b plus c into x to the power of c minus a into c plus a. So what this will become? X to the power of a minus b into a plus b is a squared minus b squared. So therefore I can write it as x to the power of a squared minus b squared into x to the power of b squared minus c squared into x to the power of c squared minus a squared. Now you can observe, dear students, this is into. Okay. Now you can observe, dear students, this x will be a base and the power will be this a squared minus b squared minus c squared minus a squared. If base is same, I can add out the powers. So therefore adding the powers, x to the power of, first you are having a squared minus b squared plus second you are having b squared minus c squared. Again third one you are having c squared minus a squared. So which will become? So you can observe, dear students, here plus a squared minus a squared will go minus b squared plus b squared minus c squared plus c squared. So what is remaining there? X power 0. What is x power? Which will be is equals to x, right? So therefore you are going to have it as, if it is getting cancelled, you are going to remain with the whole power is nothing but nothing is there, which is 0. Anything power 0 which will become 1. Correct na? So this is your answer. Is that so easier to solve the problems by using all these kind of properties? These are all will be a 1 marker and then 2 marker. In the next session, I am going to solve the 3 marker problems. So thank you, dear students. I hope this session you understood how to solve the problems based on the 3 laws of indices, and some we are going to use it in between the logically to solve problems. Isn't it? Thank you.